everyone, and welcome to the channel. What if I told you that you could write a piece of code once and then use it 1,000 times with a single word? What if you could create your own custom magic spells in JavaScript that perform complex tasks whenever you call their name? If you've ever found yourself copying and pasting the same lines of code over and over again, getting tired of the repetition, then this video is for you. Today we're unlocking one of the most powerful tools in any programmer's toolkit. We are learning about functions. Yeah, before we learn how to write a function, let's understand why they are so essential. Imagine we're writing a simple program to calculate the area of a few different rectangles. Without functions, our code might look like this. So, for rectangle 1, I write let length 1 equals to 10, semicolon. Next, let width 1 equals to 5, semicolon. And let area 1 equals to length 1 multiplied by width 1, semicolon. And console.log area 1, semicolon. Okay, that was rectangle 1. But what about rectangle 2 and 3? So we need to write them, okay? But you know what? I copy these codes and then paste them. So, and let me change 1 to 2. Okay, and for rectangle 3, again, we do the same thing. And changing to 3. So if I run it, okay, it works. But look at that. It's messy. This is a core programming principle called try. Don't repeat yourself. And we are repeating ourselves a lot here. Now, let's see how a function completely solves this. We can create a reusable tool that just does the calculation and returns the result. So for the demonstration, I write function calculate area, set of parentheses, length, comma, width, and inside curly braces I write return length multiplied by width, semicolon. Please don't worry, we're just demonstrating it, okay? And we're gonna learn all about these things. Next, I write console.log calculate area. Inside the parentheses, I write 10, comma 5. 10 for the length and 5 for the width, semicolon. And for next console.logs, I copy and paste. Okay, and I change to 8 and 3. And the third one, 12 and 7. And if I run this code, look at it, it works, and so much better. By creating a function, our code becomes reusable, clean, and easy to manage. So that's why functions exist. Now that you know the why, let's dive into the how. So let me comment these things out and write this comment. Okay. Before we write our first line of code, it's helpful to know that in JavaScript, you'll encounter functions in two main places. The first type is a standalone function, which is what we'll master today. These are general purpose tools that you can build and use anywhere in your code. The second type is a function that lives inside of a class. When a function is part of a class, we give it a special name, a method. Methods are used by creating an object from the class and calling the method on that object. It's a key part of object-oriented programming, and we will explore classes and methods in depth in a future lesson. So for today, our entire focus is on the powerful standalone function. The most common way to create one is with a function declaration. The blueprint for this has a few key parts. First, you start with a special word function. You then give your function a unique name. After the name, you must have a set of parentheses. And finally, you have a pair of curly braces, which will hold all the instructions. Let's write out that general blueprint so you can see it clearly. So I write function, function name, set of parentheses, and inside that, I write parameter 1, comma, parameter 2, and set of curly braces. And inside it, we'll write our instructions. This is called function body. Perfect, now that's on the screen. Let's walk through it one more time. The function keyword. This tells JavaScript you're starting a function definition. The function name. This is the unique name you'll use to call your function later. The parentheses. This holds the list of parameters, the inputs for your function. If there are no inputs, you still need empty parentheses. Then the curly braces. This is the function's body. Any code you write inside here is what will run every time you use your function. Okay, with the blueprint now clear in our minds, let's build our first real function. We'll make a simple tool to draw a separator line in the console. It needs no inputs, so its parentheses will be empty. So I write function, next the name of the function. This should be something descriptive, something that's clear what the function does. Okay, so I write draw separator. We have no parameters. It doesn't need it. So it will be empty. Next, I write console.log single quote. Okay, semicolon. Great! We've just defined our function. To make it work, we have to call it by writing its name followed by the parentheses. So I write here draw separator and set of parentheses, semicolon. Okay, that's the way we call a function. Just write its name, and if it needs parameters, you give it. Okay, now if I run it, yeah, it works. You see? Every time you need this function, you just need to call it. That's it. Nothing else. You just don't need to write any more instructions, no more copying and pasting. Just call the function. And I call it any amount I want to use it. It's just that easy. And see it here. Yeah. Okay, but the real power of function comes when we give them data to work with. Let's build our e-commerce calculator. Remember the parameters from our blueprint? Now we'll use them to take in a base price and a tax rate. Then we'll use the return keyword to send the final result back out of the function. Let's build it. So I write function calculate total and set of parentheses the data that we need to work with. So base price, comma, tax rate. And now you're asking me, how do I know I need parameters anyway? That is a good question. You need parameters and your function's behavior must be flexible and requires outside information to work. If a function does the exact same thing every time, it no needs parameters. However, if the function's action needs to change, it requires parameters to receive that data. For example, greet user is useless without knowing the name of the user to greet. So ask yourself, is my function's task impossible without knowing a specific value? If yes, that value should be a parameter. They are the bridge that makes your functions reusable and dynamic instead of static. Okay, next inside curly braces, I write const tags equals to base price multiplied by tax rate semicolon. Next, const total equals to base price plus tax semicolon. So we calculated the tax and then added to the base price. Next thing we want to do is to return the total. And you know what? You're asking me, and what is this return keyword? That's a great question. Look, think of a function like a little worker you give a task to. The return keyword is the finished product that the worker officially hands back to you. It stops the function's work and sends a single value out, which you can then store in a variable or use somewhere else in your code. But you know what? Some people make a mistake and get it wrong with console.log. Console.log, on the other hand, is completely different. It's not a product, it's just a status update for you, the developer. Its only job is to display a value in the console window so you can see what's going on. So, return gives a value back to the program to actually work with. But console.log just shows a value to your eyes. One is an output for your code, the other is an output for you. So I hope that made it clear to you. Perfect. Now, to use it, we call the function and pass in the actual values, which are called arguments. When you are defining a function, this thing's called parameters. But when you call the function, these things that you put inside the parentheses, we call them arguments. Let's say we're buying a shirt that costs $50 and the tax rate is 8%. The value our function returns needs to be stored in a variable. So I write const shirt price equals to calculate total, and inside the parentheses we have to give arguments. First is the base price, so $50. Next, the tax rate, and we said the tax rate is 8%. So we write 0.08 semicolon. Now let's trace it. What's going to happen? The JavaScript engine sees the function call. It finds the calculate total function blueprint that we define. It takes the two values we provided, the arguments. The first value, 50, is passed into the function's first parameter, base price. So now, inside the function, base price is 50. The second value, 8%, is passed into the second parameter, tax rate. So tax rate becomes 8%. Now we enter the function's body. The first line is const tax equals to base price multiplied by tax rate, semicolon. The engine calculates 50 times 8%, which equals 4. It creates a new constant named tax, and it stores the value 4 in it. On the next line, const total equals to base price plus tax. The engine takes base price, which is 50, and adds the tax we just found, which is 4. The result is 54. It creates another constant named total, and it stores 54 in it. Finally, we hit the last line, return tool. This is the grand finale. The function takes the value of tool, which is 54, and sends this value back out as its final answer. The function's job is now complete, and the original call, calculate total 50 and 8%, is effectively replaced by the single value it returned, 54. Okay, next I'm gonna show it into the console, console.log, backticks. Alright, the final price of the shirt is colon $, and again $, curly braces to inject our variable inside the string. Then I write shirt price semicolon. So when we run this, our function takes 50 and 8%, does the calculation, returns the value 54, and we store that in our shirt price variable. So if I run it, yeah, we see 54. Now let's buy some shoes for 120 with a different tax rate of 5%. We can use the exact same function. So I write const shoes price equals to calculate total, and for the first argument I write 120 as the base price and 0.05 for our tax rate. Next, console.log backticks the final price of the shoes is colon $, curly braces, shoes price semicolon. And if I run it, yeah, it works. You see? That's the magic of functions. Create a generic tool once and use it with different inputs to get different outputs. Nice. Now let me comment this console.logs. Okay, so you know how to build a function, but in JavaScript, there are a couple of different styles for writing them. The style we've been using is called a function declaration. It's the classic way. Let's create another function using this style. This one will convert a temperature from Celsius to Fahrenheit. The formula is Celsius times 9/5 plus 32. So I write my function in the style of function declaration. Function Celsius to Fahrenheit. Set of parentheses. And now we need the temperature in Celsius. We need that data to calculate the formula. So I have to set it as a parameter. So I write Celsius. Inside curly braces, I write const Fahrenheit equals to Celsius times 9/5 plus 32 semicolon. Now I want to return the result out of the function. So I have to write return Fahrenheit semicolon. This style of writing the function is called function declaration. So I want to use it right now. I write const temp today equals to Celsius to Fahrenheit, and we give it 25 as Celsius semicolon. And console.log backticks 25 Celsius is $, curly braces, temp today, and F semicolon. And if I run it, yeah, this works exactly as you expect. Now let me show you another way called a function expression. With an expression, we write a function without a name and assign it to a variable. That's right, in JavaScript, functions are just values. Like numbers or strings, you can store them in variables, pass them around. It's very powerful. So let's create the same converter, but this time using a function expression. Notice how the function keyword doesn't have a name after it. This is sometimes called anonymous function. First, I define a variable. Next, I assign it a function to it. This whole thing called function expression. So I write const Fahrenheit converter equals to, here I write my function without the name. So function set of parentheses Celsius, and inside the curly braces I do the same instructions I did before. So const Fahrenheit equals to Celsius times 9/5 plus 32 semicolon, and return Fahrenheit semicolon. I write const water boiling point equals to Fahrenheit converter 100 semicolon. And next, console.log backticks 100 Celsius is $ curly braces water boiling point and F semicolon. It works just the same. So we have two different ways of writing functions that do the same thing. You might be wondering, why? What's the difference? The main practical difference has to do with something called hoisting. It's a fancy word for how JavaScript prepares your code before running it. With the function declaration, JavaScript moves it to the top of its scope, so you can actually call the function before you've written it in your code. Don't worry, we're going to learn all about scopes, scope, and anything like that. For now, just accept it from me. Let's try that. I'll move the function call above the declaration. So I put my call before where the function defined. So if I run it, yeah, believe it or not, this works. But if you try to do the same thing with a function expression, you'll get an error. A function expression is stored in a variable, and you can't access a variable before it's been initialized. So I do the same for our function expression. I put my call before where it's defined. So if I run it, ooh, we get an error. So yeah, it doesn't work. With function expression, you can't do this. Now let me put it back the way it was. So which one should you use? Honestly, it's often a matter of personal style. I personally prefer function expressions because they force me to structure my code logically, define all my tools at the top before I start using them. It feels more organized, but either way is fine as long as you understand how they both work. Now for the third and most modern style, arrow functions. These were added in a version of JavaScript called ES6, and they let us write very short and clean functions. An arrow function is really just a special, shorter version of a function expression. Let's turn our temperature converter into an arrow function. For a simple one-line function, it's incredibly compact. we don't need the function keyword. If there's only one parameter, we don't even need parentheses around it. We use a fat arrow to point from the parameters to the function's body. And here's the best part. If it's a single line, you don't need curly braces. And the return is implicit, meaning it happens automatically. Watch how clean this is. So I write const Fahrenheit arrow equals to. Now here we define our parameter, which is Celsius. Normally, we would wrap parameters in parentheses, like parentheses Celsius. Notice if we had multiple parameters, we would be required to keep those parentheses. But a special rule for arrow functions is that if there is exactly one parameter, the parentheses are optional. So, for a cleaner look, we can remove them. And I do it. Next, we add the fat arrow, which is equal sign and greater sign together. So, now for the function body, the standard way would be to use curly braces and explicitly write return like this. So I put curly braces and write return Celsius times 9/5 plus 32 semicolon. However, arrow functions give us another great shortcut. If the function's only job is to calculate and return a single line of code, you can completely remove both the curly braces and the return keyword. The result is returned automatically. So let's do that now and write the final clean version. And we want to use it, so I write const room temp equals to Fahrenheit arrow 20 semicolon. And to see the result, I write console.log backticks 20 Celsius is $ curly braces room temp and if semicolon. And if I run it, yeah, it works the same. Look at that. So much shorter and easier to read for simple cases. But what if our function needs more lines of code or more than one parameter? Let's make a new function to see. This one, getWeatherAdvice, will take a temperature and a name and return a personalized message. If we need multiple parameters, we must wrap them in parentheses. And if we have more than one line of logic, we must use curly braces. And we also have to go back to using the explicit return keyword. So let's build it. Const getWeatherAdvice equals to, here, set of parentheses. And I have two parameters. So using parentheses is mandatory. Temperature, comma, name as inputs. Next, equal, greater, or fat arrow, curly braces, and inside it I write if temperature greater than 25, return backticks, it's hot today, comma, $ curly braces, name, drink water. Semicolon. Else, return, backticks, it's cool today, $ curly braces, name, maybe bring a jacket. Semicolon. And const advice for me equals to get weather advice 30, comma, single quote Alex, semicolon, and console.log advice for me. Next, const advice for friend. Get weather advice 15, comma, single quote Maria, semicolon. And to show it in the console, alright, console.log advice for friend. And if I run it, both work. So, as you can see, arrow functions are amazing for short, snappy functions, but as they get more complex, they start to look a bit more like regular function expressions. And there is a very important difference between arrow functions and the other two types, related to a special keyword called this. We'll cover this keyword in detail in a future lesson, as it's a big topic. For now, just know that arrow functions are fantastic, but they don't replace the other types entirely. My advice for you as a beginner is this: use arrow functions for quick one-line helper functions. Use function declarations or expressions for your bigger, more complex blocks of logic. The most important thing is that you understand what functions are, why they are useful, and the different ways you can write them. And that's a wrap on our introduction to JavaScript functions. If you found this lesson helpful and want to keep building your coding skills with more clear, practical tutorials like this one, please hit that like button and consider subscribing to the channel. Don't forget to turn on notifications so you won't miss the next video. Happy coding, and I'll see you in the next one.